Hello, thank you for having me here. It was a wonderful introduction that somewhat overstated my claims to existence and a role and so on. I'm one of the engineering managers in our Switzerland office, and there I lead the teams that we have in Europe who are focused on delivering on Google Search. And what I'm going to try and do over the next 30 minutes is tell you a little bit about the growth challenges that exist because of the web and how that affects search. Give you a little bit of an insight into how we evolve search over time, because search is not a static thing. And then at the end, if time permits, I'm going to show you one of the ways in which we're trying to make things more helpful and to make search more helpful at the moment. So if we can switch to my deck, I will begin. You have almost certainly seen things like this for yourselves in the past. They're Google search results. Here I've looked at the Datendialog, and I've searched for myself what we call a vanity search. And in both cases, I've been given a set of links. Relevant places in the internet, I might want to go and look for more information on these two topics. And in both of those cases, along with the link, I have a small snippet of information, a tiny bit of extra data, to help me decide whether or not I want to go and look at those particular pages, to go and seek out that particular information. People have been doing this for years. It's become normal. It's what we're used to doing. But it's not new. Search isn't new at all, and I'm going to start with a little bit of history. About a century ago, in Belgium, Henry Lafontaine and Paul Otlet put together something they called the Mundaneum. It was partly funded by Monsieur Lafontaine's Nobel Prize money. He won the Nobel Peace Prize in 1913. And the Mundaneum was an attempt to index all the world's information and make it globally available. They ended up with 16 million little index cards with text on them, and you could send them questions by mail or by telegraph, and they would reply. They would send you an answer for a small fee. Search is at least a century old. And the ambition to make it open and available to everybody, to open up the world's information, is at least a century old. Google is just one step on a long historic journey to trying to make it easier for the entire world's population to understand what the world has so far come to know. Now, it just so happens that the Mundaneum is now a museum in Mons in Belgium, and it's very close to one of our data centers. But before anyone asks, I do want to assure you, when you put in a search query, we do not send someone around to the Mundaneum to find the answer for you, except for the really hard questions. Yeah. So this is where search started in the modern sense. And now with the internet, we have rather more than 16 million cards worth of information. And we have a much more rich, a much more powerful environment. We have a pool of publishers who are putting information onto the web. A variety of people contribute information. It's government departments, it's companies, it's academic institutions, it's charities, it's all sorts of civil society groups. And it's huge numbers of individuals expressing their opinions, sharing what they know, talking about their hobbies. There's a variety of different sorts of information that go there. And it's all being published and made available for the whole world to seek out. So we have searchers looking for the information. It's a wonderful repository. But there's a problem. There's always been a problem. This is why we had libraries, why we have libraries. It's why we have reference books, why we have encyclopedias, and it's why the Mundaneum was built. The problem is there's too much information for one person to cope with. So there is this barrier between the seekers, the searchers, the users who want to find something, and the people who have made that information available, whether it's by writing a book or making a video or putting together a collection of photographs. And that barrier is getting worse, not better. Not because of a problem with technology, but simply because the amount of available information is growing so quickly. There are literally trillions of web pages. That's not millions and millions of web pages. That's millions of millions of web pages. There is no way that one person can navigate all of that unaided. The sum total of human knowledge, even just that tiny fraction of it that's so far been made available on the web, is overwhelming for any one person. You need a map. You need a guidebook of some sort. This was recognized long ago when people started building encyclopedias, and with the Mundanium a century ago, and it's just getting worse. And this is where search engines come in. The role of a search engine is purely to solve that problem. How do we help users find the information that the publishers of information, the discoverers of new facts, want to make available to them? It's not an easy problem, but the growth challenge makes it an interesting problem. Now, actually, it is easy to build a search engine. It's really easy to build a search engine that is partial, that just grabs some of the information. And it's easy to build a search engine that is adequate, that kind of helps people find some stuff. But building a good search engine and a reasonably comprehensive search engine is hard, and that's what I'm going to tell you a little bit about. Now, I'm going to start by introducing you to Googlebot. Lots of people have seen search result pages. Very few people know about Googlebot. And Googlebot is part of our search engine. And all of the search engines have an equivalent of Googlebot. And Googlebot's job is to help the publishers, the people who are running the websites, who are making the information available, to help them get the information into the index so that it will become available to the users, to the searchers who are looking for it. And Googlebot does this by sending messages. Googlebot sends out messages to people. I'll take that back. Googlebot sends out messages to websites. Sorry, I tend to personalize this too much because I think in terms of Googlebot as a being, right? Asking for copies of pages. So Googlebot will send a message to a particular web server, that's a computer on the internet, saying, please could I have a copy of this particular page? Signed Googlebot. And there's a couple of important things in there. Googlebot is asking, and Googlebot is signing the request. So the recipient computer knows that this is a message from Googlebot as against the equivalent for any other website, for any other search engine, or indeed the equivalent message from a computer that belongs to a human being who is trying to browse that site. And it is a request. Googlebot sends out lots of these messages. Googlebot sends out billions of these messages every day. That's tens upon tens of thousands of them every second, asking whether it is possible to have a copy of lots of different web pages. But even that, given that there are trillions of URLs, trillions of web pages, is still just working away at a small portion of what's available. You can, if you want to, think of Googlebot as the world's most prolific writer of begging letters. Now, what happens next is completely out with Google's control. The recipient computer decides what to do, how to respond to this question. It has been programmed to do so. It's very important to understand this. These are not messages from one human being to another. They are messages at a very low level from one computer to another, carrying these requests across the internet. And that computer that receives one of these messages must respond almost instantaneously, in a tiny fraction of a second. So it has got some pre-programming telling it what to do when it receives one of these messages. And that is configured by the owner of the website, by the people that chose to put that information on the web, whether they are individuals or organizations. And they have lots of choices about the reply. They can say, yes, here you go, here's a copy of the page. They can say, yes, here's a copy of the page, but please don't index it. They can say no, with or without a reason. It's their choice. They can, if they want to, say, now, actually, you're asking for the wrong thing. You should be asking for this information over here, a different page from their website, or indeed a page on a different website entirely. Or there may simply be silence. There may be no reply at all. That could be because that particular computer has crashed. because it's overloaded, dealing with traffic from human beings trying to read information from that site, or simply because the people that programmed that site, that control it, don't like Googlebot. Maybe they're allergic to flowers. Whatever happens, Googlebot is going to see a flood of information coming back from the people that said yes. Not everyone will say yes, but many, indeed most of those requests will be responded to with a yes, here is some information. So Googlebot has asked for copies of these pages for putting into the index, and the websites have chosen to provide that information. But they don't have to wait to be asked. It would be a problem if you were a new website that nobody knew about. Googlebot might not get round to asking you for a long time, maybe forever. So in addition to the request from Googlebot, there's also a means by which the publishers can directly tell Google search engine, we have this content and we would like you to index it. And then Googlebot will go back and make sure we get the right copy and so on. But these pages flood in. Some of them are new. Some of them are modified versions of pages that Googlebot has seen before. Some of them are exact copies, the same as the page was last time Googlebot asked for it. But it all flows in, and it becomes available content to put into the index. There is no guarantee it will all go into the index, and we'll see one reason why that is in a moment. But it's all now available for indexing. So we have this partial collection of what's available on the internet, and now we're going to try and build an index so that searchers can find their way around this. So having received the content, Googlebot now has to start dealing with it, and this is where the core of the search engine comes in. This is the process that you will sometimes hear referred to as indexing, the building of the index. The first thing we have to do with those pages is that the search engine machines, the internal machines inside our data centers, have to organize it. They have to transform it into some sort of format that we can understand and we can parse. And that begins with working out what language is this written in. Is it English? Is it German? Is it Thai? Is it French? Is it Filipino? Is it Russian? And that matters because in order to build the index, we need to break it up into meaningful words. Think about it for a moment. The index at the back of a book, and after all, that's what we're trying to build here. It's the exact equivalent of the index at the back of the book for the entirety of the web. That index is broken up by words. So we need to know what the words on the pages are. Now, in French or German or English, that's fairly easy. The words are separated with spaces. But there are languages where that is not done. So even working out where the word boundaries are on the page is a challenge, because we're doing this for the whole of the web, for every country, for every language we can get to. So we find the words on the page, know what language they're in. Now we can start thinking about building an index, right? Now, some of the words on the page are not going to be useful for searchers. There is quite a lot of web pages have stuff around the side that is the same on lots of pages. It's not helpful content. So we don't take necessarily every word that's on the page and put it into the index. And there are other things we have to do at this point as well, right? We have to work out how valuable these pages are going to be when we come to use them later in responding to the user requests, and some of the preparation for that is done now. So we will generate what we call signals as we're processing these pages. And one of the most important ones is we look at the page and we find out if there are links on this page to other pages. So the search engine builds itself a little map. For each page, it knows where the links lead to elsewhere in the web, because the web isn't separate pages. It is an interlinked, interwoven collection of pages, which is why we call it a web. And those links are useful for two things. First of all, Googlebot gets told about them and goes to try and get copies of those pages as well. If the publishers are happy to give them to us, Googlebot will get a copy. But also, we're going to use those links for one of the most important signals we have, which is a thing called PageRank. And PageRank was critical to the founding of Google. So we'll come back to that in a little while. But we're building up this collection of things, collection of words on pages, collection of information about pages. And in doing that, we are trying to work out which pages are most relevant for different possible queries. Where the words appear on the page is an important signal. For example, if a word is in the title of the page, some sort of heading at the top, then chances are this page tells you something about whatever that word means. If, however, it's buried in a footnote, maybe it's not so important. So there are all sorts of things that have to be done inside the search engine to try and assess the importance, the weight we should attach to a particular word appearing on a particular page. If a word appears on a page several times, that helps us understand that perhaps that page is about that word. Of course, if it appears on the page too many times, maybe that's someone just trying to manipulate the search engine by repeating the same word over and over again. So we have to be a little bit careful here. Not everyone who's putting material on the internet is doing it to good effect. But we build up this collection of material and signals which tell us about the value of these pages. And that allows us to make some decisions about what's going to go into the index. One of the problems is that there's too much. The web is verging on the infinite. So we have to thin things out a little bit. We don't put everything in. A more important problem, though, is that there's a huge amount of duplication on the web. The same pages may appear many, many times under different URLs, or essentially the same content may appear on different pages. So we have to make some decisions algorithmically, because this is being done very quickly on very large amounts of data, but there are decisions being made within the search engine to remove some duplicates. And that's an important part of keeping this task manageable. It would not be helpful to the users if we said, here is a really good page that's relevant to your query, and here are 200 more pages that are exactly the same as that one. Oh, and then after that, there's the next most interesting thing. You would get really upset if that's what your search engine did to you when you used it. So we have to handle this issue of duplicates from quite early on in this process. Right. But we make the decisions. So the algorithm has worked on the indexing part of this and decided this is the content that should be going into the index proper. And now we build the index. Now this is the bit that's easy-ish. We'll see why it's not quite so easy in a moment. But it's easy-ish because it really is just like building the index at the back of a book at this stage. You just choose the words that are going into the index. And for each of those words, you have a list of all the web pages that exist on the web that we're aware of that use that word. And for each of those entries, that this particular web page contains that particular word, where on the page does it appear? It's just the world's biggest thing at the back of the book that nobody ever goes and looks in unless they're trying to find something. But that's what's going to form this guidebook that we're building, this map of the web that allows the users, the searchers, to navigate. Sounds straightforward so far, doesn't it? There is a bit more to indexing than I've said. One of the problems is that the web itself is messy. There are broken websites out there that don't work properly or that give you back mangled pages. Another problem is big. It's really big. It's hard to imagine what trillions mean, but it is so hugely mind-bogglingly large that it's getting hard to appreciate just how much we know, how much humanity has discovered and chosen to tell each other all of this content on the web. Another problem is it's not only big, it's growing. There are new websites appearing every hour. There are millions upon millions of new web pages appearing every single hour. And it's continuously changing. It's not good enough to go and look at page once and be given a copy of it to work with. Pages are updated. People add comments to blogs. People correct misinformation. People elaborate on their first draft of an essay that they published and then regretted. Or they go back and modify a short story. Right? It's continually changing. And worse still, Googlebot has to be careful. Because if Googlebot went to a website and said, give me this page and this one, this one, and this one, and this one, over and over again, really, really quickly, and all of the other search engines with their equivalents of Googlebot are doing exactly the same thing at the same time, that will overwhelm those servers. Those machines will be so busy telling the search engines what they have that they won't have time to actually do what they're for, which is provide that information to users. So there's a balancing act here between how much information it will be helpful to draw into the index, how quickly we would like to check it's unchanged, and the need not to overwhelm all of those other things. But those are minor problems. They just take a ton of computers and some software. The idea is we build the index. And having built the index and dealt with the fact that because everything's changing all the time, the index keeps being out of date and we have to keep updating it, we now have to get it to a state where people can use it. So the index, as it's built, is passed out to the data centers. You saw an example in one of the talks earlier of a data center in Germany. It's not one of ours. We have data centers strategically positioned around the world in a few countries, not in every country. And those are the locations where users' queries are actually going to be dealt with. And it's important that we place the index copies carefully. We can't have too many copies of it. The index is huge, so we need to be careful about the resources involved there. But it's important that we have copies of the index available close to where the users are. Because our whole purpose as a search engine is to help users find the web pages they want to go and visit. We need to do that quickly. And if the search index itself is close to the user, that shaves a little bit of time off what it takes to answer the question, to actually provide that response. The goal is to do it in the blink of an eye. We're not quite there yet, but we're working on it, and you'll see later one of the steps we've taken to try and get closer to that. So the questions come in. Let's see what's happened there. Is that me? Oh, my apologies. I'm going to have to keep this thing calm. Give you some idea of how long my password is. So we have to get the search index out to where the users can quickly interact with it. Also, having multiple copies of the index is helpful because it allows us to cope with issues around reliability. What if there was a problem with one of those data centers? It's not acceptable for the search engines, the big ones that people rely on, to stop working. Right? We must continue to answer the questions from the users no matter what. So we have multiple copies in case something goes wrong with one of them. And also, that careful positioning allows us to keep our costs down. It keeps it a little bit cheaper. By placing the search index copies in the right places, we reduce the cost to ourselves. We can choose places where building a data center makes sense. It's cheaper to run, the electricity is available, and so on. And that allows us to offer it at the rate that users want it at, which is free. No one pays us for their search results. This is an interesting challenge. And this is one of the differences from the Mundanium. They had to charge people. They hadn't solved their monetization problem. You had to pay them for your answer. All right, so we've built an index. What happens next? Well, this is where users start to see the reality of a search engine. They will send in a query, and we will find possible answers. So the search index, whichever copy of the index they're interacting with, will put together a list of possible answers. Now, here we come to the second interesting historical part of this story. When the web first started, the equivalent of the search indexes were essentially directories. They were lists of sites. You could go and look at one of these, and it would say, this is a really good site for information about football. This is a really good site for information about film. And that worked really well for not very long at all in the lifetime of the web. It was very rapidly overwhelmed because the human editors couldn't keep up. There was simply too much information too quickly. It was fine when we were in the very early days of the web, when it was a few hundred websites, but it rapidly disintegrated. And so we moved on to the automatic search engines. And if you were an early user of the web, then you may remember some of the names. Probably one of the most famous, one of the best of the search engines at the time was AltaVista. And these were automated systems that found what was on the web and organized it into indexes, exactly as I've described so far. That worked fine, and it became very important that the search engines did a good job because they were replicating the act of the human editors, But rather than choosing what to put in their list, they put everything they could in the lists. But there was one thing they still did the same. They put the list in order. A list is inherently ordered. Now, when there were 10 or 20 places to find information on a particular topic, it was okay. Users could, if they wanted to, go to all of those 10 or 20 places. By the time the automated search engines were needed, it wasn't 10 or 20 places anymore. It was hundreds of places. And a user was not going to be able to go and check all of them. So the order the results were put in mattered a lot. You needed to get the most useful things to the top of that list so that users would be guided fairly quickly to good places. Nowadays, because of the growth of the web, we're at millions upon millions of answers for every query. So that ordering is ever more important. It's critical. So having got all these possible answers, we're looking at however many million answers it might be, they are put in order. This is a process we call ranking. And ranking really matters because it's the thing that the publishers care about most. It's how they make their material available. They want to be high in this ranking. So we put the answers in order, and that ranking depends on those signals. Things like PageRank, which says this page is more important because other pages are referring to it. Other pages are linking to this, so this is a good site. And that allows the users to click on their early results based on these snippets that have been given to them and choose to go to a page. The page I'm using here as my example, by the way, is the BSI website because we have a BSI speaker later. And it's full of interesting security information. Lots of people should know about it, and they don't visit it enough, but it's available in the search engine. There's a challenge to ranking. I'm not going to go into the details of it, but that ordering has to be done dynamically. Every query is different. You see, it's not just that the web is growing, roughly doubling in size every 18 months. It's also that the queries keep being new. 16% of the queries we see every day we have never seen before. We can't have pre-prepared answers. So that ordering of the results has to be done in that blink of an eye. And having done that, we also then have to pull out those snippets and prepare them to give back to the users, because those snippets are generated related to the particular query that was asked. They're not standardized. But it works. It's not magic, it's just engineering. And it relies on the availability of data about what is on the web and how the pages are interleaved. But having built this, there are now other things we can do. So having talked about the challenge of scale, I'm going to tell you a little bit more about how search engines manage to be helpful using data. This is a spelling correction in action. I've misspelt Saxony as I typed this query in. But what has happened, you'll notice, is that it's been corrected by the search engine, and the correct spelling of Saxony is there. If I really want the original spelling, I'm allowed to go and click on that. You know, the link is available, and I'll be given search results for Saxoin. But the search engine has provided me with its best guess based on the behavior of previous users. Right? So this is using signals collected from the use of the search engine to work out how to correct spellings. And the reason it's this way round, giving you the corrected results and an option to go and find the uncorrected ones, is democracy in action. This is correct for the users. On average, most users who make that mistake, or who type that thing in, have made a spelling mistake and want these new results. Whereas there may be a very few who really were looking for SAXOYN, and they can still get to results for that if they want to. This is one way of saving people some time. Without this, you'd have to correct your spelling mistake and try again. There's other things we can do to save time. We have this autocomplete mechanism, again, driven entirely by the behavior of users. What searches are they making? So that as you are typing, we look and see what are the possible completions of what you're typing. So the search engine, the indexes themselves, are choosing possible extensions, and the most popular are put at the top of this list. And to save you time, as you type in your query, whatever is the most popular, the most significant of those autocompletes, is fetched for you in the background. That gets us much closer to the blink of an eye, because as you type, the results are arriving before you've even finished formulating your query. Of course, this is only useful if the guess is right. If I'm not looking for a company's website here, because Bayer is a company, if instead I'm interested in something to do with Bayern Munich, the football team, well, what do? The answer is simple. I stop typing and I hit down arrow twice. And before I finish doing that almost, without me even having to hit enter, I get the results for Bayern Munich. Now, don't get too excited by the thing on the right. It's not available in German yet, but I'll talk about it in a moment. But you can see what's happening here. Information to do with Bayern Munich that might be what this user is interested in is pulled up. I'm told Bayern Munich are having a great start to the season and that the result on the 2nd of October was an anomaly. I'm not a football fan, so I have to admit I don't care. But it seemed like a relevant topic given so many of my colleagues are based in Munich. So this is a way of making things go that little bit quicker, saving hundreds of millions of people a few seconds each every time they search. That adds up to a lot of human lifetimes that we have speeded up. But it's not enough to build a search engine and to make it better and to use the data we have to improve it, to use the data to do spellings, to use the data to do autocomplete. We also have to keep making it better. Like all of the other search engines, we're in this continuous process of improvement. And it's helpful if people have an idea of how exactly ranking works and how it's changed. We made 500 plus changes to the search algorithm last year. And I'm just going to very quickly tell you how that works. It starts with an idea. One of the search engineers thinks, we could try this. We have lots and lots of ideas, and some of them are completely bad ideas, like let's make every page that's written in white ink on a white background be at the top of the ranking. That's a very bad idea. It would not get anywhere. But quite a lot of the ideas are plausible. And those we try and build. We implement them internally, thousands upon thousands of them. We try to build them. Some of them, it turns out, we can't build. We don't know how to build them. Some of them we can build, but they require so much computational power, they're not usable. Some of them work, but they're just too slow. They would slow the results down. That's not acceptable. But the ones that we manage to implement that seem to work okay, those we test. And we test them by looking at what they do to the rankings, what they do to this ordering that is at the core of your search results. So we generate some samples, and we show them to external raters, and they say, I prefer this one to that one. Sometimes they even tell us why. And that helps us work out whether we're getting, on balance, more improvements rather than more problems with this change. And for the changes that seem to give us lots of improvements that we've managed to implement, we actually do an experiment on you, the users. At any given time, we are running a collection of experiments with the search results where a few people, tiny fraction of people, see a slightly different ordering. And we look at what the consequences of that are on those real queries. And an analyst prepares a report, and everything that's not fallen by the wayside, that still seems to be doing well, goes to a review committee that decide, do we make this change or not, based on data. Based on lots of different sorts of data collected over a period of time investigating this change. In 2010, we implemented over 13,000 ideas and just over 500 launched. In 2011, even more ideas were tried, well over 13,000, and we launched 500 and something changes again. Right? This is the core of how it works. And it's important that the webmasters in particular, people who use the search engine, know this. So we've released information about this. The screenshot on the top left is actually of a ranking meeting. We released a video of them discussing a possible change to how spelling correction is done. You can watch it. It's got annotations to explain what's going on. They're all busy looking at a screen full of data at this point in the conversation. And we blog about the changes. Every month we announce how many changes we've made and roughly what sorts of things they affected. And we have a website dedicated to the webmasters telling them how things work with forums to help them. And bottom right, you can see one of my team in a Hangout. He's using Google Plus in an open public Hangout where webmasters can come and talk to him about how the search engine works. This particular Hangout was being conducted in German. He's a native German speaker. We do this other than just in English, even though everyone thinks we're an American company. But for normal users who don't care about that level of detail, we also have a website called Inside Search. We'll come back to that. We have lots of search boxes, but they're all fundamentally the same. There is an index of available content, and there is an ordering, a ranking algorithm to make it available, whether it's for images or maps or news or the core search. And over time, this has got richer as an ecosystem. I'm being told I'm running late. We've combined these things together. We've brought the maps and the web pages and the images together, and that gives you universal search. It's the most important change we've made over the years. Right? We have allowed people searching in one box to see pictures and web pages and videos and maps all at the same time. And the latest change we're making is something called the knowledge graph. In my last 1.5 minutes, I'm going to just quickly run you through what the knowledge graph can do. I did that by a Munich search on google.com in English. And it pulled up that thing on the right, which is a summary of information about that particular entity. The knowledge graph is 500 million entities. These are famous places, people, and entities with 3.5 billion links and relationships between them. Attributes of those things, like where something is, what, who wrote a particular book, and so on. Right? And that information is drawn from open sources, and it's allowed us to automatically create things like you're seeing on the right. Or if I repeated my Saxony search from earlier, a knowledge graph entry for Saxony can appear. Here's a knowledge graph entry for an American architect, Frank Lloyd Wright, and it tells you his biography, some of the projects he's famous for, things like Falling Water and so on. Here we have 2 knowledge cards, one on the left for the first commander of an American space shuttle, one on the right for a musician. But what's interesting to note here is that the knowledge card for the astronaut tells you which space mission she was on, how long she spent in space, whereas for the musician, it's telling you about their songs. This is not hand-curated. This is not the equivalent of the beginning of the web when people made lists by hand. This is automatically generated from the data that is available on the web. Machines algorithmically decided that you would be most interested in space missions for the astronaut and songs for the songstress. And you can explore the knowledge cards. So you can click on something in a knowledge card and open up a related knowledge card. So you could discover, if you're looking at a particular amusement site in North America, that your children have to be more than a certain height to get onto a particular ride. Or this one came up in our testing. If you're interested in The Simpsons and click on the creator, you will discover his family members' names, and you'll discover he named the characters after his relatives. Homer is his father's name. Lisa is his sister's name. We didn't know that until people started testing the knowledge graph. And sometimes it's not entirely clear what you're looking for. This is an example from the US of someone searching for kings. They could mean either of 2 sports teams or maybe a particular TV show. So we make it easy for you to disambiguate, to choose which one you want, and then show you the results. And you've seen that again in the Saxony example at the bottom. We've also identified, algorithmically, there are other things called Saxony in Germany. There's more than one state with Saxony in its name. Of course, this could be wrong. This information has come from the open web, and the web changes. Facts change. Who someone is married to, or the height restrictions on a particular amusement ride change over time. So it's possible to report corrections, and we will feed those back to the original data sources. This is my last slide, and it's my favorite feature. Sometimes when you look for information, the answer is not one thing. Sometimes there is not a single answer that makes sense to put at the top of the search rankings. For example, if you search for Charles Dickens books, you want a collection. You want to know all of the available books. And the knowledge graph allows that, and it presents those results across the top so you can click through them quickly and easily. So that's just one aspect of where search is going, a little bit of an insight into how we change it. And hopefully, I've given you some idea of the complexity behind what we're doing to try and make this wonderful thing The web is easily the greatest single collection, single largest accessible collection of human knowledge, human insights, human understanding. Make it so that people can use it, so they can find things. That's what search engines are for, and this, very superficially, is how we do it. If you want to know more, go to Inside Search. There's a lot more information there. I hope that was helpful. I hope it was interesting.